Well, hello again, everyone. This is Dr. Sturgis, and in this video, I'm going to continue discussing your second homework assignment. Um, so in the last video, we talked about number one. So we talked about how to conduct the correlation analysis in Excel, and then how to do the regression analysis to get your significance levels for your correlation coefficients. So you should be in good shape to conduct number one here. Number two, it says to create tables and scatter plots and paste all of them here. So let's switch over to Excel, and I will show you how to do that part. Okay, so for number two, again, it says to make tables, and I think one table is plenty. So you want to make a table that looks like this, and you'll notice that up at the top, the first variable is monthly income. And the way that you read this, for example, the 0.46 correlation between age and monthly income. So readers will know that that's the correlation between age and monthly income. In the cell right below that 0.46, where you put the correlation for education, again, readers will know that that's the correlation between education and monthly income. The other thing you'll notice on this table is I took away the median value. And again, the reason for that is that it's just not typical to present a median in a descriptive statistics and correlations table. So again, for this part, basically you're just going to make a table that looks like this and fill in all those blanks there. The next thing that you do is you make a scatter plot. And again, in the first video, I showed you how to make that scatter plot, and it just involves checking the appropriate box there when you're doing the regression analysis. You'll notice that this one looks a little bit better. I went in and I formatted it by adding a title, the age versus monthly income at the top. I started the age. You can go in and you can pick where you want to start the axes at. So I moved that over to 20. I put in some titles there for age and monthly income, the vertical and horizontal axis. And then I changed the colors just so they contrast and they look a little bit better. Again, the general idea is just to make it attractive so that the reader, when they look at it, they understand what is happening with the table. I'm sorry, with the chart. So that should take care of number two. So let's switch back to the assignment. So number three, so it says explain your findings in detail, the strength of the correlation of each variable with monthly income, and the direction of linear relationship, positive or negative correlation. So again, that's fairly straightforward. Go back to the Excel. So for the first one, so we calculated the correlation between age and monthly income to be 0.46. So it's a positive relationship because again, the R it's positive. It's greater than zero. A positive relationship just means as age goes up, monthly income tends to go up as well. Again, if you look at the scatter plot, you can see that that's what this data is telling us. As people get older, their monthly income goes up, tends to go up. And that just makes sense that, as older people, they advance in their positions and their positions are paid more. So we've got that, and then the homework had asked you to talk about if it's significant. And significance, what that refers to is, do these sample findings generalize to a larger population? And so again, that's given by the significance. And on the table, again, we talked about putting three asterisks. So it's 0.46 with three asterisks. And if you looked at the key, three asterisks means that p is less than 0.001. And again, typically people are not really interested in exactly what your p-value is, just that it's less than 0.05 or less than 0.01, etc. And so again, what that's telling you is that yes, these sample findings, they do tend to generalize to a larger population. The third thing about interpreting a correlation is, what exactly does the 0.46 mean? Um, well, when we talked about the regression output a bit, you see that again the multiple R is equal to your correlation coefficient. And so then the R squared and the adjusted R squared, which you can see in this output, the numbers are just a little bit different. The adjusted R squared, the reason it's adjusted is that it's adjusted to reflect sample findings into a population. So it's saying that in the population, we think that the R squared would be about this number. In any case, the R squared, the adjusted R squared, you just take the multiple R and you square it, or you multiply it by itself. And the interpretation of that is that, for example, the 0.21, if you make that a percentage by multiplying by 100, so the interpretation is that we're explaining about 21.5% of the variance. So age explains about 21.5% of the variance in monthly income in our data. So let's move back to the assignment. And so number 4, it says, based upon your learnings from this activity, explain variables that show a significant linear relationship with employee attrition. And so again, as I've mentioned, so I did not personally write this assignment. And so with that caveat, you probably already know that employee attrition, so it's a binary variable, which means that it's coded 0 and 1. 0, the person did not leave the company. 1 means that they did leave the company. So with that said, you don't really have a linear relationship, right? You would have some values grouped at 0 and some values grouped at 1 if you made a scatter plot. So it's not technically a linear relationship. And if you were doing something like this in your job, keep in mind that the appropriate way to do this would be to conduct what's known as binary logistic regression, which you can do in Excel. If you go in and you type in the formula in the solver and so forth, but it's a bit beyond the scope of this course. So again, if you're called upon to do something like this in your job, just keep in mind that term binary logistic regression. Conduct some research on your own, and you'd be able to do that. For this assignment, let's just conduct the correlation between employee attrition and some of the variables in number 1. So, for example, age, probably makes sense that as people get older, maybe they leave the company for a different position. The same thing with education. People get a new degree, they decide to move companies, move positions. Distance from home kind of makes sense. If you're working a long distance from home and you can't work from home, then it kind of makes sense that you would search for a company that was closer to where you lived. So again, just pick some of those variables in number one, maybe three variables, and conduct the correlation between employee attrition and some of those variables that you selected. Um, so again, you'll do it the same way that you did number one. You'll do the correlations, then you'll do the regression to get the significance values. And again, since it's not truly a linear relationship, you have to be careful in when you interpret the correlations. But you can tell if by the significance values of the correlation coefficients whether for example, age is a significant predictor of attrition and so on and so forth. Okay, so that takes care of the first part of your second homework assignment. And in the next video, I will talk about part number 2 of your assignment. So we'll pick it up there in the next video.